The event will begin in 5 minutes. Also, just just a quick reminder, please ensure that both your cameras and microphones are off during the event. Welcome to the third breakout room, everyone. Before introducing our esteemed resource speaker for today, I would just like to say a few words as one of the webinar organizers of the second day of Software Engineering Day 2022. First and foremost, good afternoon to each of our participants within this breakout room. This is Jason Season, your host for this afternoon's breakout room, and on behalf of my classmates from the BS Computer Engineering 44, welcome to Edge. IoT meets the cloud. I know that I also speak for my classmates when I say that we are honored to have you all as participants. I hope that, like me, you are all pumped up and ready to listen to gather more knowledge about the industry as we learn from today's presentation. At this juncture, I would like to introduce a resource speaker for today. He is a cloud professional. He is a Google Cloud certified professional cloud architect who is also an AWS cloud practitioner, a Microsoft certified in Azure fundamentals, an Oracle Cloud infrastructure certified associate, and an Alibaba Cloud associate. Everyone, let us all welcome our speaker for today, Mr. Romar Cablao.
Ayan. So, hello guys. Good afternoon. Let me just work on with my camera for a while. Here you go. So, hello everyone. Thank you, Jason, for introducing me and for inviting me in your session. So, should we now proceed?
Yes, sir. You may now
Perfect.
call.
Let me share my screen for a while. By the way, just in case I get disconnected or if you feel like I'm being choppy, just do let me know so that I could adjust.
Will do, sir. Thank you.
Great. For a while, let me just work on some other items in my screen. And here you go. So again, thank you guys for having me in this session. And of course to those attendees. I know it's 1 p.m. and maybe some of you, nakakaantok, di ba? Normally kapag hapon. But I am happy that you attend this session and hopefully you get something from me, especially on the concept of edge together with cloud computing. So what would be our agenda today will be these items, right? So we will first discuss about edge computing. Let's take a look on how we could actually compare it with cloud computing. I believe that there are sessions previously held in PUP, relating to cloud computing. So I believe most of you, if not most of you at least, um, know already some of the fundamentals relating to cloud. We'll also take a look at how computing milestones or the computing milestones timeline rather, where edge computing really started from. And then later on, we will now be merging these two concepts, these two worlds. We have the edge computing, we have the cloud computing, and how we can really benefit, or extend the benefits of those two worlds. How we can extend the benefit of cloud computing and have it like used for us to be able to power up computing at edge. We'll take a look at some examples as well and use cases later on, especially when using cloud and how these cloud providers can actually help us, even as a student, no, even hindi pa tayo practitioner talaga, even we're still working as not working, even we're still as a student, no, we can actually make use of it in terms of our thesis, maybe a pet projects or so. And later on, we'll be having two sets of demo. We will be having a demo relating to content delivery network or CDN using AWS CloudFront. And then we'll take a look at AWS IoT Core and IoT Greengrass, where we could check how we could install local runtime outside the cloud. And even though it is outside the cloud, how can we get to have the benefit of those two worlds? How can we connect those items and concepts and so so basically, the demo would be in between the concepts. So I'll be turning off my camera during the demo because I need to plug in my mouse, by the way, for accessibility. By the way, let's start with this overview. So let's start with these questions. No? So is edge computing really about mobile technology? Is it about Internet of Things? Well, basically, you see on the banner, on the title itself, there's an IoT there. So is it really about edge computing, and how is it related to? Is it about smart environments? I believe you have heard about smart cities, smart buildings. I believe also you have heard about Alexa, Amazon Echo, the device itself, where in it is powered by Amazon Alexa and Lex, right? You also have like an idea, I guess, of smartwatch, smart TVs. So how are those things related to edge computing? Is it just really about cloud? Is it about just really hosting it on premise or running it on a specific device? Is it about just computing since it's edge computing? How about the networking stuff? Is it still related to that? And early this morning, if you have attended the sessions relating to 5G, you might have heard IoT in there and how IoT have, no, not how 5G actually powers up IoT, right? Well, basically, even 4G can power IoT, but with limitation, of course, especially when you are working with voluminous number of data and, of course, voluminous number of sensors that generates those data. When we talk about edge computing, we can also ask ourselves, does it apply to robots in factory or in manufacturing companies that actually monitors the equipments or a sort of those that monitors in an operating room? Have you watched a video like those robots that do the actual, say for instance, doing the operation, no, inside the hospital, and then the ones who is actually controlling it is somewhere far away from that robot or machine. It's maybe somewhere on a different country, but it is actually connecting over the internet. So how does that thing possible? Or is it still related to driverless cars? Those sensors, those embedded systems that are part of a big thing, just like driverless cars, right? So later on, we'll see how these things um, can be grouped together. But basically, all in all, these things that you can see on the screen are actually related to edge computing. So simply put, let's first define edge computing. So it's pretty straightforward. When we talk about edge computing, it actually enables data produced by IoT devices, by edge devices, by edge thing. So just hold on for those terminology. Later on, we will discuss more further of those. Um, those data that are produced by IoT devices to be processed closer to where it was actually created rather than this is created here in the Philippines and then if you forward mo pa somewhere else. Just like, let's say our server is actually hosted in a data center in the US. So the problem there is that you have to consider the latency, the time that the data you are actually forwarding to the server or to the destination, kung gaano katagal yon makakarating and kung gaano katagal natin mare-receive yung response. So that would be a problem in terms of those systems, applications, devices, or use cases na kailangan talaga real time, no? And very, very critical na instant dapat yung result. And the best use case of it is actually driverless car, wherein we put up sensors. Now, whenever it detects object, right, it needs to stop immediately. Otherwise, you might get crushed to that object. So instead of doing the processing to the cloud, sending all of the data that it captures from the sensor, so probably no, when you send it to the cloud and do the processing there, might be you will receive or you might get the response late na or delayed. And the problem with that is that you might get crushed already when you get that action or response. So that's really, really critical no for those kind of scenario, yung latency and yung speed ng action, yung response ng action. So basically, instead of traveling to the cloud, data is processed, analyzed, and it gets filtered directly on the device. If not on that device, it should be somewhere else near that device. We could actually leverage on the data center offered by these telco companies, right? Globe, PLDT do have their own data center. And we could actually leverage on their 5G offering to actually trim down or reduce the latency for us to be able to get into their server, for us to be able to use their server as an edge facility, right? So according to Gartner, they actually published this. So around 10% of enterprise generated data is created and processed outside a traditional data center or outside the cloud. And by 2025, Gartner predicts that this figure will reach to 75%. And most likely, if it gets bigger and bigger, meaning we will get to have a problem in terms of the storage, where we will put those data generated by other devices. Also, we also need to consider the latency, the bandwidth, right? If we are going to send it to the cloud, then we have to consider the cost it will incur. Because basically, if you move data across other data center or you move it to cloud, it will actually incur cost. And the more data you send, the more data, the more cost you will pay for, right? So basically, that's the thing that we need to be aware of so that we could prepare an architecture on how we could just leverage both of two worlds. Where can we use edge computing? Where can we use cloud computing? Where can we use both of them? No? There are some use cases. So I'm not saying na dapat edge computing. I'm not saying na dapat cloud computing. There are use cases na much better si cloud. There are use cases na mas okay or much better si edge computing. And in relation to that published article, most machine data or most machine generated data are actually not reaching the cloud. So they are mainly processed locally or within the premise where that device is actually located. So just think of industrial machinery, right? About manufacturing plants. A lot of their data gets processed and needs to be responded quickly. Hence, most likely they have their own, let's say, a small facility that do some sort of computing. Or the device itself that collects the data, that generates the data, just in case there are changes within the environment. Let's say a sensor that monitors temperature, the sensor that measures humidity, the sensor that checks on if the equipment still properly work. Because if not, 'di ba, it will affect the production. And if it affects the production, it will affect the business as a whole. So as much as possible, there are some use cases like this that we really need to put all those things, the compute capacity, the compute capability, as much as possible near to that object. Another instance is about medical equipment. A lot of times, medical computational transactions are very short and may contain personal identifiable information or PIIs, right? There are actually laws that actually ensures that there should be privacy, the Data Privacy Act. So it is actually imposed. So there are also companies, organizations that they really want to have their data being stored and processed only within their premise, within the perimeter of their organization, within their let's say data center. There are also countries that enforces law that all data generated within this country should be bounded only within this country. It shouldn't go outside of it. One example of it is China, right? They have strict implementation when it comes to uh, data privacy. So same way with medical equipments, as much as possible for those data not to be leaked somewhere else, it should be it's much better to process it within that device or within an edge location closer to you. And then the third one here is a situation in which an environment where there is a very low network connectivity if if sometimes nga wala pa no. So just like for instance, an example here is a Mars rover, those that are actually deployed on Mars. So most likely they have this compute capability that manage some sort of image processing so that the built images will just be sent na lang back to the Earth. So sometimes data processing needs to be happen at the device itself, especially for those environments na walang internet connectivity or walang way to communicate to a data center or to a higher facility na merong higher computing power. So why edge computing? There are actually four factors driving computing to move at the edge. Or these are actually the four imperatives driving compute. to the edge. So there are four laws that are actually connected to it or tied to it. We have law of physics, law of economy or economics, law of the land, and then Murphy's law. Let's start with law of physics. So when we talk about law of physics, maybe we could um, talk about latency and network, right? The time your request gets to the server and up until that server returns a response back to you. So law of physics basically given there's a constant speed, the more na malayo yung destination, of course matagal kang makakarating. And the nearer the destination, mas mabilis kang makakarating. So same concept applies with networking. So if you send data over the cloud, it may get to multiple components. It will get to have multiple hops to those components before it reaches nga yung destination na server natin, right? Especially if it is located in the other part of the world. So that might be a problem, no? The latency. So we have also to consider that. And that's actually one of the driving factor why we want to make use of edge computing. Second is law of economics or law of economy, which means that sending information to the cloud carries a cost. Of course, we pay for subscription for internet bandwidth, right? All of us know that one, that's really a cost. Aside from that, for us to be able to use this medium, be it a wireless ones or a wired ones, we need to purchase, of course, the equipment. We need to hire people who would assemble those components, who will monitor, who will maintain and operate those equipments. So that's a sort of operation. So lagging my cost. So that's why when we talk about bandwidth, no, if we push on data, a lot of data, it will actually incur more cost because you consume much more bandwidth. Plus, if you are moving data no, from different location, you also have to consider the storage. And of course, storage, meron rin yang kaakibat na cost. Okay, so that's law of economics. You pay for the resources you use as the more data you process, the more data you move, no, mas lumalaki rin yung. And then the third law is law of the land, which is almost related to the one that I have mentioned a while ago, the example with China, right? That they have strict implementation when it comes to data that they are producing. It should be bounded within that country only, no? So it deals with the compliance, security, privacy, regulations. So there are customers, there are organizations, there are companies that they really just want to keep their data as much as possible close to them, right? Especially those data that are actually sensitive, PIIs or personal identifiable information, as well as those data that relates to credentials. And even the port numbers and IP addresses of your infrastructure, those are considered as sensitive information. Hence, those information needs to be secured. And the fourth one is Murphy's Law. Anything that can go down or can go wrong will go wrong. Hence, when you are into architecting infrastructure, no, you have to consider availability, fault tolerance, redundancy, and those three that I have mentioned can be achieved using cloud, right? If you are architecting in GCP, in AWS, in Azure, or any other cloud providers, you have to consider those things. Because going back to that law, no, we are thinking of that failure will happen. Hence, we will plan for that failure, even if that failure didn't happen yet or hindi pa siya nangyayari. Para in case that fault or failure happens, our infrastructure is actually ready. No? And that's what we call fault tolerance. It can go up if any failure happens. If, let's say one availability zone gets down, you still have two more availability zones, something like that. This is just a continuation. I have mentioned the first one, the main benefit of why using edge, especially for specific use cases like the one I have mentioned a while ago, which is self-driving cars, where we put in, sensors that needs to respond as much as possible, very, very quick, right? So this is the main benefit of moving computing at the edge, as much as possible to the device itself. So it reduces latency to support real-time processing. Second, files can be kept locally in case of limited bandwidth. Meaning, if you have your own, let's say, rack of servers, you are managing those servers, you can make use of it, no, as staging area. Just in case you have limited bandwidth and you cannot push all of your data all at once to a destination, be it on another data center co-location or on the cloud. So you can make use of that as your staging ones. And that is also connected to the third one, data filtering. And if you can manage that within your organization or at edge, then you get to have the capability to do some sort of filtering, to do aggregation. And it is also connected uh, to controls in terms of sensitive information. Just like what I have mentioned a while ago, if your company organization happens to be like adhering to these regulations, na dapat yung data created within our organization should only live within this organization. So you can actually filter out ano ba yung sensitive information na hindi ko dapat i-forward. So with Edge, you can actually do some sort of validation, aggregation, filtering like that. The fourth one here is access to files in offline mode. Well, basically, if you are managing it, your own server running on your organization within your company, so you could make use of that, as your storage. So even in the advent of internet failure, as in nawala ng internet, biglang for whatever reason nawala ng internet. As long as you have still your internal network set up, you can still do or continue your business, right? So that's one of the benefits of it. If there are benefits, we also need to consider the challenges that we might face when getting into this approach, right? So first and foremost is scale and performance. Given that we are the ones managing these physical components, these devices, right, within our organization, deployed on, let's say, our company. So we are the ones responsible in terms of scaling that one and ensuring that they are performing well. Hence, we need to set up monitors, right, to check on the health and statuses. Additionally, we need to be we will be the ones responsible in terms of the power and cooling of the servers because we'll be the one managing those, the physical servers. And of course, for us to be able to enable the communication between those servers, we have to set up networking cables. And that would be an additional task. And that would be that might be tedious, right? If you are just, if you are just few people within your organization that works in your IT infrastructure. So that might be a problem. Second is control and security. Given that you are managing it within your organization, right? You will also be the one responsible in terms of the controls and setting up of policies. Who can access this? What at what level they can access to that specific resources. That also includes the security, right? You have to consider the security not only on the application itself, but also to the physical component. Because given that you are managing it or hosting it within your organization or company, you'll be the one responsible in securing uh, that devices, right? So organization would be the third one here. So just think of managing edge the same way with managing data center, given that you have multiple teams working on different slices of works, be it on the networking, may DBA, may sysad, right? Merong IAM related, merong sa security. So nagkakaroon ng silos, right? And for you to be able to like power up those things all together, you have to add up resource that knows how to operate, how to maintain those equipments. Otherwise, 'di ba, nag-invest ka lang sa components pero hindi mo naman magagamit kasi wala nag-ooperate, wala nagma-manage, wala nagme-maintain. So you have to invest not only to the physical components, to the compute components, you also have to invest in terms of the skills ng employee na magma-manage ng mga components na yun. And that will actually incur cost. That's one of the challenges as well. Especially if you are not that big company or if you are a startup, that would be a challenge. And then the fourth bullet here is heterogeneity. So when we talk about this, it happens to be relating to Internet of Things. When you are managing multiple devices, be it a custom one, let's say you create a microcontroller with this kind of sensor, you have a custom Raspberry Pi, and then you have another one for Arduino, and then you also another one that is actually bought from a third party. We will just, you know, use it out of the box. So iba-iba yung component. And given na iba-iba yung component or devices na mina-manage natin, it means that we also need to have some sort of a way and process kung paano ma-manage yung mga components na yun. And later on, these challenges that we are discussing will or will not will but can also be solved with the help of cloud computing. So in the next slide, there's a quick video for a while. Let me just share the sound. Here you go. So this is just an introductory to cloud computing.
Cloud computing is the on-demand delivery of IT resources via the internet, with pay-as-you-go pricing. Instead of buying, owning, and maintaining physical data centers and servers, you can access technology services such as computing power, storage, and databases on an as-needed basis from a cloud provider like Amazon Web Services. Organizations of every type, size, and industry are using the cloud for a wide variety of use cases, such as data backup, disaster recovery, email, virtual desktops, software development and testing, big data analytics, and customer-facing web applications. For example, healthcare companies are using the cloud to develop more personalized treatments for patients. Financial services companies are using the cloud to power real-time fraud detection and prevention. And video game makers are using the cloud to deliver online games to millions of players around the world. With cloud computing, your business can become more agile, reduce costs, instantly scale, and deploy globally in minutes. Cloud computing gives you instant access to a broad range of technologies so you can innovate faster and build nearly anything you can imagine. From infrastructure services such as compute, storage, and databases, to Internet of Things, machine learning, data analytics, and much more. You can deploy technology services in a matter of minutes and get from idea to implementation several orders of magnitude faster than before. This gives you the freedom to experiment and test new ideas to differentiate customer experiences and transform your business, such as adding machine learning and intelligence to your applications in order to personalize experiences for your customers and improve their engagement. You don't need to make large upfront investments in hardware and overpay for capacity you don't use. Instead, you can trade capital expense for variable expense and only pay for IT as you consume it. With cloud computing, you access resources from the cloud in real time, as they're needed. You can scale these resources up and down to grow or shrink capacity instantly as your business needs change. Cloud computing also makes it easy to expand to new regions and deploy globally in minutes. For example, Amazon Web Services has infrastructure all over the world, so you're able to deploy your application in multiple physical locations in just a few clicks. Putting applications in closer proximity to end users reduces latency and improves their experience. No matter your location, size, or industry, the cloud frees you from managing infrastructure and data centers so you can focus on what matters most to your business.
Okay. So basically, that is just a high level um, overview of what really cloud is. That is actually a material, no, from AWS. But the concept discussed a while ago actually applies not only to AWS. It could also be applied to Azure, to Google Cloud, to Alibaba, to Oracle, to Tencent, to Huawei, and to other cloud providers out there. So let us just summarize those items into 6 bullets. This is actually coming from AWS as well. So number one is trade capital expense for variable expense. So when we talk about capital expense, is just that you are actually moving into a pay-as-you-go model, or instead of you investing all at once for a physical components or data center, just for you to have this kind of computing capability or capacity. So with that, with pay-as-you-go model or pricing, you could actually you will only pay for the service you use, and if you are not, if you are not using this all the time, you could actually save much more cost. A second is benefit from massive economies of scale. So what does this mean? When AWS grow, no, we also get the benefit of getting like the prices of some services and resources gets also lowered, and hence customers, users also gets benefited. Number three would be stop guessing the capacity, meaning you can actually um, set up whatever the instance type needed, just in case I just need it for testing. Maybe you can spawn up T2 or T3 micro or T3 small, wherein there would be some sort of one vCPU to vCPU, or a lower memory capacity, just for the testing. If it is related to machine learning and it is in GPU intensive, well, you can select a different instance type for you to be able to do certain functionality, right? So with cloud provider, you can select with variety of options. Um, you can customize as well depending on your use cases, and you don't have to just simply guess, I need 6 instances, but when you deploy your application you just need 2. When you do that one, you purchase, you create a purchase order, no, kapag data center, bibili ka ng 6 racks of servers, tapos when the deployment happens, hindi pala kailangan lahat yun. So sayang, sobra yung binayaran natin, and hindi natin nako-consume or na ma-maximize yung resources that we have pa. As compared to cloud, just in case that you need to increase the number of instances, you can just simply increase or enable auto scaling, and then automatically based on demand, your instances, can scale horizontally or can scale vertically depending on what you have set up. And with that, you can save cost. Whenever it is not in use, it will scale in or scale out. So basically, you save cost with that kind of approach. And then number four would be increased speed and agility. With this one, especially for those business that are into or using technology, or are actually technology yung parang um, infrastructure nila for them to be able to do their business, it is very, very important to deploy and deliver value the fastest. It will give them the ability to deliver more. That's the agility part, and many valuable components, so that they could benefit from selling those, be it a solution or be it a SaaS solution. So number five would be stop spending money running and maintaining data centers. So instead of you putting up your investment into setting up your data center, your own data center, maybe you could just consider renting out to the cloud and then leverage on the benefits of the auto scaling, redundancy, availability. No, if hindi naman talaga need or hindi naman talaga yun yung forte ng business mo. If you are just a small company that is just starting, maybe you could explore more of the cloud. Well, actually, most of the startup are actually leveraging the cloud. The reason being is that they can easily deploy. They can easily deploy new features, because just think of cloud as pre-built solutions. Before kasi parang ang thinking ng mga tao is just a repository. But now, it's a repository of solutions and services. Think of it as building blocks. So you can put these components just several clicks, you could actually deploy your application. You could just simply write it and deploy it as a function using serverless, right? Using a cloud function, using Azure function, using AWS Lambda. Just simply write your code and then deploy it there, and then that's it. It's available everywhere, right? You can easily deploy it even in other region. Even if you are just in the Philippines and then meron kang customer or client in the US, maybe you could set up a server or an instance in a data center near the US so that it would be much more faster for them to access. So it's pretty easy to spin up instances, servers, deploy applications with these cloud providers, and could also be done with just clicks. Now, given those benefits of leveraging the cloud, now how can we extend those cloud capabilities to the edge, right? Can we really bring benefits of cloud to IoT edge? Before we answer this, let's have a quick look at the milestones timeline or where edge computing really started from. So, the origin of edge computing can actually be traced back in the early 90s. As you can see in here, um, when Akamai launched its CDN solution or content delivery network. The idea was actually to introduce nodes at location geographically closer to end users for the delivery of cached or static content such as images, videos, be it a document that needs to be downloaded, a work docs, a worksheet, or any sort of files that your user, your client would need to. So maybe that's the initial start, no, where edge computing can be seen. Kasi we are actually bringing contents closer to the user. Again, when we bring those content closer to the user, meaning we are reducing the latency, mas mabilis, and that improves the user experience. Familiar kayo sa meme na to? I believe you have seen this in Facebook, in Reddit, or any other social media sites. No, someone asked which server is fastest. Facebook, Google. No, it's localhost. Well, basically, he has a point. If you are working, if you are a developer, if you are a programmer, right? You are developing your code in your laptop, on your device, be it your laptop or your desktop, and then you are running your API, and then you are running your front end at that same machine. So basically, the connection or connectivity where the front end request to backend would be much more faster. So mas mabilis talaga siya in a sense, right? But that's very different when we deploy it na in a server, right? Because that server might be deployed in a different region, in a different availability zone, or in a different place na merong different way of connecting to. So those are the things that we need to consider then. So going back to the milestone timelines, around 1997, pervasive computing was actually introduced. It is almost the same with ubiquitous computing or computing everywhere. It's just that there's a rise of, improved energy consumption with speech recognition, cyber foraging, and then with the use of mobile technologies and so on and so forth. Around 2001, peer-to-peer computing and networking was actually introduced. Familiar with torrent? I believe most of you have heard torrent, right? So actually, torrent has a bad image. Torrent has a bad image, right? You know the reason? It's because most of the people are using it for sharing and downloading pirated softwares, pirated contents, videos, right? That's why it has a bad image. But basically, very, very helpful yung approach or yung concept ni torrenting, no? Because you are actually sending bits of files to someone else nodes or computers, and then for you to be able to get files or content, you just have to tap your nearest node and then ask, meron ka bang content na ganito? I need to get it. So, can I get that one? So, meaning, kapag mas malapit yung pinagkukuhanan mo, mas mabilis yung response and you get to have low latency. And then around 2006, this is where cloud computing started when AWS, Amazon Web Services, offered their first two services. Actually, two services. It's S3 and EC2. So S3 is for storage, and then EC2 is for virtual servers, virtual machines, right? So Amazon EC2 stands for elastic cloud compute. And again, as I've mentioned, these are virtual servers where you can deploy your applications. And then around 2009 and 2012, cloudlet and fog computing was actually introduced. It sits actually in the middle of cloud computing and then edge computing. So in the middle, you have cloudlet and fog computing, but we will not be focusing on those two concepts. What we will be focusing on is cloud and edge technology and how they can actually communicate, and then how can we leverage both of those two worlds. Now, if we go back to the question a while ago, how can we leverage on cloud computing and extend its capability, extend its benefit, for us to be able to power our edge computing? So these are the benefits, no, when we get those two worlds merged or combined. We get to have the capability to flexibly deploy application with at most zero downtime, because we get to have the redundancy, availability. We could also have this rich API support for easy integration of heterogeneous services, be it a local ones or a remote ones. With cloud computing, they also offers yung SDKs, yung API, and even CLI for you to be able to interact with the platform and for you to be able to do automation, no, in terms of, given that there's an infrastructure as a code already, no, you can simply provision things, provision instances, provision serverless component by using CLI, by using SDK or API provided by them. So it's pretty straightforward, right? Next is synchronization between devices, edge, and the cloud. Well, basically, you could communicate these things, edge things, to your cloud provider, be it an AWS, Azure, or GCP. You could also have the benefit of offline and online mode, which is also connected to local processing, wherein you could have the capability to filter, aggregate, decrypt, encrypt, decode, encode, and all other computing function and logic that you could do for you to perform anything within your data. And that would also lead to edge analytics. Once you have data, you do some sort of analysis, processing, right, for you to be able to get insight from it. You could also have the benefit of polyglot protocol support, meaning you could select specific, not specific, you are not tied to a specific protocol. Let's say you are not just tied for HTTPS. You could play around with other protocols, right? If you're familiar with MQTT or message queue, telemetry transport, you could actually make use of that, especially for IoT. Those are actually used, most commonly for Internet of Things. So polyglot means you can select different protocol, for different use cases. You are not tied to a single one. And then last two bullets, simplified device access and unified application APIs. And that is actually offered by cloud providers. You have the sets of APIs, you have the sets of documentation for these APIs, for you to be able to spawn up the server, for you to be able to provision this database, for you to be able to deploy a serverless component, and so on and so forth. For you to be able to also connect your edge devices to the cloud, for you to be able to communicate these devices internally, using your gateway that is installed on an edge location. You also have this support for different IoT domain needs. So might as well you are working into manufacturing company. So might be iba yung use case nila as compared dun sa medical. Maybe iba yung need nila sa scientifical, those that are into, exploring the outer space or into mining rin, di ba? Iba-iba yung domain, iba-iba ng use cases. So might as well we need to consider those. And we could actually leverage Internet of Things for those use cases. So let's start with our first demo. So the first demo would be focusing on the CDN part, the one that I have mentioned a while ago. How are we going to bring content closer to your user, right? For them to be able to get the benefit of low latency and for them to be able to easily access that website, that application, and so. Have you tried opening a website pero ang tagal niya mag-load? maybe the server where that application or um, web application is hosted is somewhere far from you, maybe in the US, right? That's why it is like it would took time before it loads. So how can we actually solve that problem if just in case your application needs to be accessed globally and we need to distribute this um, across the globe? So what we will be doing now is we will be architecting. Well, actually, this is already available. We no longer need to architect. We will be provisioning these resources. We'll be creating this architecture into a provision resources. So in high level, we'll be having this component which is very essential. No? This is CloudFront, AWS CloudFront. This would serve as our CDN or content delivery network, a way of caching our static contents closer to our user. So putting it to the edge nodes or somewhere closer to our users. At the back of it, let's have a quick run through. We have three components. I mean, group of components. So we have here API. API would be normally dynamic yan, diba? Depending on whatever the user has requested. Whatever the user has um, included dun sa payload ng request. So it will then gets processed using a serverless um, service here, which is a Lambda function. So basically, Lambda function, just to give you an overview of it, Lambda function is a serverless approach in deploying your application. You just simply write your, let's say, if you are into Python, just write your Python function and then paste it there, and then you're good to go. You can trigger it directly. Well, basically, AWS Lambda now supports URL, so you can trigger it directly. You can also put it at the back of an API gateway. API gateway will serve as our proxy, our facade, our entry point, our door, before tayo makapasok or matrigger si Lambda. So that's it for the API. Well, basically, this is a dynamic ones, and we will not be storing cache for dynamic, right? The middle ones here is an S3 bucket. So S3 bucket is an object storage. You can store files in there, be it a video, an image, a work document, a worksheet, and any kind of files or objects. You can store it in there. You could also host static website with S3. Just like if you create HTML files, JavaScript files, CSS files, it can be hosted in an S3 bucket. And that's what we're checking on later on. We also have this media package. This is a way of ensuring lang naman yung videos and contents mo for security as well. But still, it will fetch those files or videos or contents in an S3 bucket. So we have three endpoints at the back of our CloudFront, one dynamic and then two static where we could cache yung mga static content. So let me switch for a while. Let me first switch off my camera so that I can plug in my mouse for easy accessibility. So let me just walk you through with AWS Management Console. Okay. So in here, we are actually seeing the AWS Management Console. And in here, there are a lot of services, right? But we'll basically focus more on CDN and Internet of Things later on. So for now, what we'll be checking on is CloudFront. Actually, I have pre-created the resources so that it won't take too much time for provisioning. We can just simply discuss what are the provision resources and how these components works together. So let's click on CloudFront and then open it. In here, I do have several projects. but we will just be focusing on the latest one, which is June 10. I just open this one. This is actually the the provision resources, no, based dun sa architecture I have presented a while ago. So in here, if we check on the origin, we have three origin, meaning these are the source na nagsaserve ng content. One is for API, one is for video, and one is yung hosted sa S3. And then the behaviors, think of these behaviors as your rules. These rules are actually validated whenever you access the website. And it is referring to the path pattern. So if you have the endpoint and then you append this path, what will happen here is that CloudFront will check on saan ba nakapoint si API. It is pointed to API origin. What if I just type in the root, the URL at the root path? So it will just be redirected to the S3. So it will fetch the static content from S3 and then it will load for you. What if I clicked on the out path? It will provide us a video that we can play with. We could also create some sort of error messages here if we would like to do some sort of like 403 or unauthorized access or 504 if there's any problem within the server, right? We could also set geographic restrictions, meaning if the application we build is only allowed or we would like to deploy it or available within the Philippines, then we could set here a list to where to what countries we would allow that service, or we could block those countries that are listed here. So for now, I'll not be changing this. We could also have, basically when we're talking with caching, we also need to consider what if I have updated the S3 files. I need to check on how it would look like if I deploy it. But sometimes it would take quite some time before those changes gets reflected, and it's because of the cache time, right? So if in case that you really need to see the updated version, you can create invalidation here. So what will happen when you specify an invalidation here? It will just clear out the cache and then it will fetch the new version of your templates of your static site that you have uploaded somewhere else. So in this case, in S3. So let's try to view this one. So you can actually check this using the link, using this link. So if we open this one, it should be available to you as well. You should be able to see something like this. As you can see, this is actually in the root path, right? There's no slash in front of it or no other path in front of it. So just the root path. And then this is actually the static content coming from S3. How can we verify that it is really coming from S3? If we open the debugger tool, development tool, let's reload this and then check on this root path and then check on these headers. We could actually see the server is set to Amazon S3. I think it's quite small. So it's in here. It is actually fetched from Amazon S3. So nasan to si Amazon S3 na to? So hanapin natin siya. So as I mentioned a while ago, S3 is just a storage option or solution you can make use in the cloud, wherein you could also host application or static contents. Oops, I think I have a lot of files in here. So let's check on the latest one. So in here, as you can see, we have the 404 HTML, we have the API echo, we have the favicon icon, we have here the some of the assets, the CSS, the JavaScript, the index.html, which is our landing page, right? So you can see in here. So those are actually stored in this S3 bucket. And then just simply, you know, being called by CloudFront whenever we trigger this endpoint. Now let me check if this is available publicly. So as you can see, this is set publicly. Hence, you can easily access this um, S3 S3 objects. But we will not be doing that. What I am just showing you is that with CloudFront, you could actually cache those static content, be it on S3 bucket or in other services, even on an EC2 instance, you can actually cache it. And as you can see in here, this X cache um, component here has a value of hit from CloudFront. So meaning uh, we are just simply getting those cached content which are stored to a location nearest to us. So what will happen here if I do some sort of invalidation? So if even if I do a reload here, right? Oops, hard reload and check on this one, it's still saying it is hitting from the cloud front. So if I'm going to like create an invalidation here, as I mentioned a while ago, if you would like to change items within the static files or static contents that we have uploaded in S3, we could create an invalidation here so that it would get or it would fetch those new items. So for now, what I'll be doing is to create an invalidation and then I'll just put in the root path. Then it will just invalidate everything. This might take quite some time, maybe 1 or 2 minutes, but let's see. What I'm trying to get here is that I don't want to see this hit from CloudFront. I want to see miss from CloudFront because we have invalidated the initial cache, and so it will refetch the new files or data that are saved within your S3 or within other storages where you put those static contents. So let us just wait for a few more minutes, seconds, I guess. And then let's try to reload this. So still it is hit from CloudFront. Still hit from CloudFront. Well, basically, if this will not work, since probably some might open this site, right, using the link I've sent. So maybe we could check on with the API because the API is a dynamic one. So that is where we can see miss from CloudFront. So where can we see that API? So if I click this API here, as you can see, the API gets load immediately. The reason behind that is because this template is actually part of the static content. And then whenever a response coming from an API gets into, or what do you call this one? If that particular request has been fulfilled, so you get a response, and then that response will get displayed in this template. That's why you see when I reload it, you will first see the API, then for quite some time it will then load this content. And to verify that, we could actually check this echo um, component here. If we check this one, you will see X hyphen cache is actually set to miss from CloudFront. It's because it's a dynamic content and we are not storing it as cache. And if we're not storing it as cache, it would actually take quite some time to load because the request will still be processed at the Lambda function and then it will return back a response before it gets displayed in here. Again, that's the reason why API gets displayed first because this template, including the API here, is actually coming from the static file. And then this thing here is actually injected as soon as the response coming from the API um, gets into CloudFront, right? So that's the thing here. You can actually set configuration here, the behaviors of those patterns or those paths. You could set it as like caching disabled, so as you can see in here. You could also set caching optimized, meaning you enable caching and then it is optimized for a specific service. In this case, it is optimized for S3's use cases. So now, if we go back here at the API or the website, sample website, we could also go into the media wherein a video is actually loaded. So as you can see, it will still took quite some time because it will fetch some information, including this signed URL or pre-signed URL. And then as it loaded, we can now simply play that video. And this video is actually coming from the S3 bucket. So that's pretty much it. With the help of CloudFront, we could actually enable caching. We could also enable path-based routes. No, if we are like having an API at the back end, which is using different service, be it running on an EC2 instance, be it running on a serverless function like Lambda, be it running on a container running or and orchestrated in Amazon EKS or ECS. So you could actually point it in here. Okay. So so far, do you have any questions, clarifications that you would like to ask as of this moment before I move on to the other concept or the other um, demo that we will be doing? By the way, with the next demo, we will be having the setting up. If you have any questions as of the moment relating to CloudFront, relating to how CloudFront is related to edge computing, well, basically, with CloudFront, you enable this content being delivered to the customers, to the users, closer to them, giving them the benefit of um, fetching those files the fastest, lower latency, and which will result to better user experience. So again, if you have any questions, violent reactions that you would ask relating to CDN, CloudFront, are there any other are there any other CDN solutions out there that we can make use of? Yes. Actually, all of the cloud providers do have their own solution. You can also use Cloudflare if you're familiar with Cloudflare. So there are a lot actually. Okay. So I guess here, so there's a question here. Is edge computing also important in pursuing a front-end career? At what point or how will you think will it be necessary? So actually, in a sense, yes. If you are into designing your internal UI for this, how do you call this one? For this edge thing, right? For you to be able to manage it, for you to be able to have a visualization of it. Yes, in a sense, it's still important. The concept is important. Plus, if you are using CDN, right, for front end, you also have to consider yung mga static content for your front end. Kasi if your front end has a dynamic content tapos in-enable mo yung caching, that might be a problem because every time you load it, which if it needs to be a dynamic response, no, even if you reload it multiple times, you will get the same response. So normally nagiging problem yan na, uy, nag-push na ako ng update, it should be readily and available. Pero when you visit the website, the URL, the link, hindi pa rin nagre-reflect. And it is maybe because you enable the caching, pero that particular path shouldn't be cached at all kasi dynamic dapat siya. So yes, important siya in a way, you know the concept para alam mo na whenever it needs to be deployed in the operation side, you know what would be its effect. So I hope that answers your question. And so anything else that you would like to ask? Okay, let me go back to the slide for a while so that we could discuss more further about IoT or Internet of Things. So now this is just one example, the CDN part, a way of like delivering, contents closer to your user. The other way around is, of course, Internet of Things, which is normally running sensors, devices running locally, deployed on the fields, deployed on or within your company. And so we need to consider how those data and how those devices connects to one another and how those data are being aggregated, filtered, and processed. So in this slide, I get it from IoT Analytics. This is actually from February 2022, so just recently. There are several services that are actually offered by different cloud providers, but most numbers of these services are actually coming from AWS. That's why I selected AWS para consistent yung demo natin. Right? So with AWS, you can play around with a lot of services, not only with Internet of Things, there are actually 200 plus. And if you ask me kung kaya ko i-name yung 200 plus na yun, well, basically no, I cannot name all of those. There are too many. But in here, we could just simply focus on AWS IoT Greengrass, where we could use it as an edge runtime. We could install it on an edge facility, edge location on a server, and even on your machine or laptop. If just in case that you would like to just simply try it and then explore it, right? You can install it on a Windows, on a Linux, on a Raspberry Pi, right? For you to be able to play around it. And then we'll also discuss about more of on IoT Core, a cloud solution where you can connect your devices to the cloud. Pretty straightforward, so that all of the management would be done on the cloud. You get to have a single pane of glass, meaning you could get to have a single dashboard where you could monitor these devices, especially when we're
Good
talking with
practices. I am quite confident that you
devices
will gain new
or
learning
IoT
experience
devices at
here in the
scale.
webinar.
When I say at scale,
Once
it's not
again, I
only 10,
welcome
it's
you.
not only
I
20,
wish
it's
you
not only
all here
50.
a very
We're
successful
talking about
webinar. Thank you.
thousands, hundreds of thousands, millions, hundreds of millions of devices.
Thank
So
you,
thank
Miss
you
So
very
Nicole,
handling fleet
for
of
those
those
kind
devices
words.
would
We
be
could start
tedious.
this
Managing
webinar
those would
session
be
and a
tedious.
heartwarming
Hence,
welcome
we
to
need to
all of
have some
our
sort of a tool, a
participants.
management tool that could
So
help
this
us
webinar
managing
is
those
about clean
devices,
code and
right?
code
So we
refactoring
could
in Java.
actually leverage
So
on
what
these
can you say
services,
about
as you
this,
can see in
Jervin?
front, but we will just simply
You know
focus
what,
again, as I've
Alondra?
mentioned, with IoT
Based aking
Greengrass
basic Google
IoT
search,
Core.
code refactoring
Before
is
we
a
go into
DevOps
that,
software
what are the
development
customers
method
are doing with
that
AWS
entails
IoT
altering
or
and
Internet of
cleaning
Things?
up previously
These are
produced
just
software
common use
systems
cases, no?
without
Actually,
compromising the
nag-mention na
code's
rin tayo kanina
functionality.
during the start
Napaka-interesting,
of
di
this
ba,
session.
Alondra?
So, first
Yes, of
here is
course
to
naman,
improve the
Jervin.
performance and
Napaka-interesting ng
productivity
topic
of
natin ngayon.
industrial
Kahapon
processes,
nga, Jervin,
especially
ang
those
mga computer engineering
machines
student natin
that
ng
needs to be
Polytechnic
monitored if
University
they
of the
are
Philippines ay
functioning well
nag-showcase ng
or not.
kani-kanilang gawang
Because if
software,
not, it might
mapa-website
affect again the
application,
production,
mobile
and if the
application, at kung
production
ano-ano pang
gets
mga
affected,
innovations.
the
Ang
business
galing, di ba,
will be
Jervin?
affected.
Oo naman, Alondra, ang gagaling
Remotely
talaga ng
monitor
ating mga
patient health and
estudyante.
wellness
Ang dami kong
applications.
nakitang mga applications na sobrang
Maybe an
useful
example of
kapag
this would
na-deploy sa
be
public. Pero
smartwatches, right?
Alondra,
You can
alam mo,
monitor
mas
pulses, and so it can also be applied to like hospitals wherein there's a sensor that monitors a patient, right? And if hindi nakapag-report agad yung sensor na yon, which is critical, of course, where things might, go bad. So, kailangan talaga responsive or instantaneous yung mga ganitong use cases natin. And then we have this track inventory levels and manage warehouse operations. You could also use it, to build smarter products and user experience in homes, buildings, and cities. That's where smart cities, smart buildings, smart homes came from. You're using Amazon Echo, right? Alexa, open the light, something like that. So you get to communicate with a device, and then that device tries to connect to other sensors or other device connected to it for it to trigger an action. So that's an example of it. Though I remember this one, I think I haven't mentioned this a while ago. If you have tried Google Home as well as Amazon Echo, sometimes if you say a request to it, diba, you will notice that there is some sort of lag before siya mag-respond back. The reason behind that is that device do not do the processing within that device itself. What it does is it will get the input, it will get the message you have said as an input, forwards it to the cloud, and then do the processing in the cloud, and then just respond back whatever the action needed. So what happens there is that there's a latency problem here that you can notice. But yeah, maybe for some sort of Alexa thing, hindi naman siya ganun ka critical. But if that is applied to self-driving car, doon na siya nagiging critical, which is on this part, right? Kasi it would cause an accident na if super delay or super late yung respond or action for any changes that happens on your environment. Say for instance, mayroong obstruction in front of me and then I need to stop. Pero hindi na stop kasi walang trigger na, okay, I need to stop kasi hindi na process or it's still waiting for the response, no, na processed from the cloud. So these are just some use cases, no, that customers, organizations, companies are doing with AWS IoT. So let's have a quick view of this.
Building device software can be a long process, and customers often find themselves reinventing the wheel. Device builders want to easily build, deploy, and manage device software for use in homes, factories, vehicles, and businesses. This requires developing and debugging applications on a variety of test devices and deploying software on millions of devices globally. AWS IoT Greengrass helps you accelerate time to market and reduce costs in two ways. First, it lets you quickly build intelligent device software with a robust edge runtime. And second, it lets you remotely deploy and manage device software. AWS IoT Greengrass enables local processing, messaging, data management, and ML inference, and offers pre-built components and building blocks to help you develop edge applications faster. It also provides a secure way to seamlessly connect your edge devices to any AWS service, such as Amazon Kinesis, CloudWatch, or S3, as well as to third-party services. Once software development is complete, you can deploy and manage your software on millions of devices in the field without needing a firmware update. IoT devices have a long lifespan, and the ability to remotely update software is critical in keeping devices up to date and making them smarter over time. You can install the AWS IoT Greengrass client software on IoT devices or on hubs. Hubs allow other edge devices to communicate with each other even without a cloud connection. AWS IoT Greengrass helps you build and manage your device software, allowing you to invest more time and energy in your core value proposition. To learn more, visit our website.
Okay, so that was actually a high-level overview of what AWS Greengrass is. We could actually make use of it as a runtime engine that is actually installed on an edge facility, not on an edge facility, on a server running on an edge facility or even on a device, right? I can click next. Here you go. So basically, moving forward from this point, we will be discussing more of an IoT core and Greengrass. So again, just to differentiate the two, IoT core lets you connect billions of IoT devices and route trillions of messages to AWS services without you managing the infrastructure. Again, this is a managed service. You just have to worry about those devices at hand, meaning those that are deployed on your location. You're the ones responsible with that. But for managing it, managing the physical servers running on the cloud, that's not your problem anymore. That's the cloud providers a task to do the auto scaling and all sorts of that. With AWS IoT Greengrass, on the other hand, it is actually an open source edge runtime. Again, an edge runtime, meaning you can install it on a server, on a device running on any edge location. There's also a cloud service where you could connect this edge runtime to the cloud. That also helps you building, deploying, and managing device and softwares. Not only single, but could also be fleets of devices or core devices. So high level overview of it, still continuation. If we go back to the definition of IoT Greengrass, we could install it at the edge, meaning it is outside the cloud. As you can see, this is Amazon Cloud, and this is somewhere maybe on a co-location near you, a data center managed by a telco company near you, or a device that you actually manage within your organization. So meaning it's really at your hand and you can play around with the installation and sort of things. But of course, when you make use of AWS IoT Greengrass Core client software, you could also get the benefit of it being connected to AWS services, meaning it will act as your gateway, as your mediator for you to be able to still leverage on the capability benefits that we can get from cloud. We could trigger Lambda function, we could forward to S3, we could do analytics, right? We could, set up some sort of analytics and to get better insight as well. So this is what we're going to do later on. We will be installing IoT Greengrass client software at a device running on a local server, local machine, basically my laptop, and it is just running on a virtual box so that it would be like isolated. And then that example or that instance would be a sort of like it is outside AWS, just to test that it is really outside AWS and we're not running to the cloud, but we are connecting to the cloud. Another diagram here would show us how we could leverage on IoT Greengrass core device in terms of how we can leverage AI ML inferencing or inference. So in a way, we could leverage cloud for training, creating model, optimizing that model, and when it fits in with the requirement, then that model that was actually created, we will then forward it or we will create it as a component and then deploy it in for devices. So meaning, all of the tedious task of training, doing some sort of creating the model, all of the computational power will be handled by cloud, but the output of it, which is the model, will then be used by the IoT core device. So that whenever an inference needs to be done, it no longer needs to go to the cloud. Just simply consume those models that are deployed within your IoT Greengrass core devices. And that would be deployed as a component. Okay. It is modularized. You can create one component, another component for different use case, and then another component for another use case, right? Not only for AI, could also be for analytics, could also be for just simply validating the file structure or just simply validating if it is really a file or not. So Greengrass core use cases, these are just the three, no? So core would be the local actions and remote control, meaning you get to have the benefit of triggering an action, triggering a process at edge wherein you deploy that device or that green grass core device. And with that, you also get to have a remote control that can connect to AWS, that can trigger Lambda function, that can trigger um, a website or some sort of like that. And then we also have this machine learning inference, which I have mentioned a while ago in the previous slide. And then we could also get the ability to extract, aggregate, load the data generated from the sensors that we have, right? So those are the core use cases. And this is just an additional. So run at the edge, meaning we could deploy it. We could deploy or install the client SDK and then have it connected to the cloud, but still it is running at the edge, meaning closer to us. And when it is closer to us, it would be much more faster, meaning low latency, right? So next is control fleets. This is actually the answer to edge challenges a while ago, right? When it comes to scalability, when it comes to control and security, because we will be having now a dashboard, a single pane of glass where we can all manage those devices. And we could use AWS Greengrass for that. And if we can manage those devices, we could also deploy applications or so-called components. Just in case we have updated a component that validates a file, or let's say a component that is doing AI or ML inference, then we could do versioning, right? And then deploy the latest version over the air or on the fly. Meaning we no longer need to go to that device, no, one by one and then install it manually. So it would be much more easier if we like register this core device, Greengrass core device, and then whenever there are new changes or updates within our components or logics, then it would be much more easier kasi it's in just a single, not a single, but in just clicks no, of a button or even using CLI or using SDK, you can manage the updation of those components across multiple devices. Again, across multiple devices. You could also do the process. You could also do local processing in here, as mentioned a while ago. Okay, so we're now heading to our last part of the session, the demo for Internet of Things using Greengrass. So what we're going to do here is to deploy and set up AWS IoT Greengrass. But I have two set up actually. I have one running in AWS using AWS Cloud9, just in case we get to have any issues encountered when we deploy locally. So there's just a backup. And then we will deploy a component, right? Using AWS, pero it will then be synced dun sa edge device natin, which is running on my machine. We will then be deploy a sort of component. I guess we will skip the publisher and subscriber. We will just simply deploy this image classification component. So a sort of medyo related kay ML, right? So yeah, let me switch my screen back to AWS Management Console. In here, let me just close some of the items in here. For us to get into the dashboard of Internet of Things, we can actually search IoT. Here, there are a lot of services actually, but we will not be discussing all of those. We will just focusing on IoT core. Let me click this. And then Greengrass. IoT Greengrass. Okay, so let's start with Internet of Things or IoT core. So let me go through a learn tab here and then start the tutorial. So why I am showing this to you is because with this example, we could see how this device could actually communicate with AWS Cloud and how this AWS Cloud that actually serve as broker triggers a certain action or activity to the destination, be it a destination device or a source device. So in here, what we have here is just this control. So think of it as your mobile phone that is connected to the cloud, and then you are sending a message to the cloud that I think I need to open my lamp, or I forgot to close or to turn off the light in let's say in the house. So I need to like trigger it and then turn off using my mobile device without me doing it like kailangan ko pa umuwi ng bahay para lang patayin mo. So you have this device, you have this controller, and then just tell the cloud, please turn this off, and then it will just turn that off. So something like that. So the control would be starting from, of course, the controller, the one that triggers the action. And then it will then send to the cloud, IoT core to be specific, as long as the destination or the device it needs to manage is registered in IoT core, it will know that, okay, this is the destination for it. So in a high level, the request is actually sent to the broker. This broker will look for that device and then tell on that you need to open. And then that's it. It will actually open. Again, you need to register all of the devices. You need to register the things. These are called things in AWS. No, those devices that are actually connecting to it are actually called thing. Now, whenever I need to, say for instance, turn it off, then it will just turn it off, or just simply change the light to this kind of color. It will do the same. So it's pretty straightforward, right? But in here, if we go to green grass, let's skip this one and go to green grass. With green grass, we could do it locally. So instead of your devices connecting to IoT core, you can just have a connectivity of it internally or locally as long as you have this green grass edge runtime installed. So that would be your gateway, so that those devices locally or set up locally could communicate to one another. And then Greengrass edge runtime would be the ones responsible in telling or connecting to AWS on any other activity, action, request that has been um, requested. So in here, what we're going to do first is to create a Greengrass device. So as you can see, when I go here, I'll be setting up one core device. So that would be the device that will handle the logic and do some sort of processing and will act as gateway, our gateway, right? So how are we going to do that? So in here, I'll be clicking set up one core device, and we just have to name it whatever we want to, right? So maybe let's try to change this as PUP demo, and then I'll just have it. Let's create a new group so that it would be like isolated. Then group in here, right? So this would be the name of your core device that will be registered in AWS. And then this would be the group where that device will be part of. And then we have two options here. We can install in Linux or Windows, but basically we could also install in Raspberry Pi. As long as you can install Java, basically prerequisite or the requirement would be a Java installed on your device or machine. So that would be the ones responsible in powering up our Greengrass application. So in here, what I'll be doing is I'll be just moving this for a while in another screen because I need to import um, some credentials for me to be able to consume later on. Perfect. So let me put this back again here. So this is where we will be working at. This is actually running on my local machine, running on VirtualBox, as you can see in here, just for the demo. And as of the moment, there is no installed Greengrass in here. What we're going to do is to actually follow through the instruction. We just need to follow through the instruction. Let me just have it side by side na lang, right? Para kita natin. So pretty straightforward. When you create core device, AWS will tell you what to do next. So I have done this already. And then we will now be proceeding with the next steps. So actually, this step is actually done already because I built it with a Vagrant and some sort of automation tool. I have built this additional user and group as well. So we'll now be doing this, downloading the installer. So let us just copy this. What it does is, using curl, we will download these binaries. This will be then extracted into our working directory and then inside this folder. Let's click enter. Okay, perfect. So let us just list the file in here. So as you can see, this is the downloaded file, the binary, and then this is the extracted ones. Now, what's the next step that we need to do? Let's go back in here and then run the installer. Since it is installed or extracted in Greengrass core, it's this one. So no other things or no other action needed, no? Just simply copy this since same lang rin naman yung name nung path to where those extracted files or binaries are saved. So I'll be just copying this and then pasting it here and then click enter. So as you can see, using this, using Java, basically, we will be just, extracting this binary, putting it into the directory that we would like to put on. And then that is where we will be like running the CLI for us to like register the thing, which is connected to the one that we have created a while ago, the core name. This is the group name, right? And then basically this is just a Linux user and group. And then we have this provisioning here. It will first create keys and certificate that will be used to attach and verify no yung instance na to AWS. So it will then gets registered and then gets validated that okay, this device is registered and validated. Okay, to kilala ko to. And we will be trusting this device for any activity or any request that it needs to do. Now, as you can see, it do all of the stuff for us automatically in just by just using this, command. It will attach the necessary certificate. It will attach the necessary role and policy for us to be able to communicate with other components. Say, for instance, if we would like to use MQTT for messaging, or if we would like to um, subscribe or publish a message to a topic. So that is part of those roles and is automatically be created for us. Some of those will be created for us. Well, for the custom ones, will be the ones responsible in creating those, of course. Then, as you can see in here, it is now successfully configured. The core component of Greengrass um, client is the nucleus. So that actually act as your orchestrator, meaning nucleus is the one responsible in managing all of the components that we will be deploying later on. So this would be like your brain or the brain of Greengrass. So now it is installed already. Just to verify that it is installed, let us check the root directory if there's a Greengrass in here. Basically, this is where the CLI resides and some other configuration. And then what I'll do next is to just simply list the available component. So let me just copy a command here. So as you can see, these are the components na built in when we create or when we install Greengrass Edge runtime. The first time, we will get to have the nucleus. As I've mentioned, this would be your orchestrator that will manage all other components. We have here the telemetry agent. We have here some other components, as well as this CLI. Okay, so for us to be able to verify that it is also available in AWS, we can go back here. Let me just close this. We can check on that we have actually created this core device. Is named -tup demo, right? So when we click this one, you should be able to see the version as well as the version of some of the components. Well, basically pre-installed always the CLI. And it is version 256. Where can we see that one? It is also visible somewhere here, which is this one, version 256. Now, if you would like to deploy additional components, say for instance, a component that is publicly available and then we just want to consume its functionality, how are we going to do that? It's pretty straightforward. We just have to like create a deployment and then create or search for that public component, add it, customize it, and then deploy it automatically using AWS Greengrass Management Console. You can deploy it without you touching this device, this component, as long as it is already installed and connected to AWS Greengrass. Now, the next thing here is that we will check on the deployment. Let me pull off some. Let me just validate first all of the components in here. As of the moment, we have this 1, 2, 3, 4, 5, and 6. Okay. Now we will be deploying I guess 3 to 4 more components. And what we'll be doing is that we'll be referencing this. Let me just pull off the documents and we will then move to the deployment proper. Perfect. So now what if we would like to deploy components aside from this main component that is actually built in when we install Greengrass Edge client the first time. So what if gusto ko ng custom or what if gusto ko ng components na available somewhere else? Now what I'm going to do here is that I will go to deployment. Let me open this. That I'll be going to deployments. Okay. And then look for the group where we actually put the core device in, which is this one. This is the group, right? And then in here, what I'm going to do next is to actually do a revision. So meaning you can do a version control in here. You can delete version, you can upgrade to new version if in case na merong new version yung component na gusto nyong gamitin. And then if we click this revise deployment, we'll be having this UI. It will just ask some details. We'll just proceed with public components. We will no longer create custom ones. I'll be searching for several components here, which will be used for PubSub or for publishing a topic, and then one component will be the ones responsible in some sort of subscribing to that topic or consuming those topics that are being published. So I'll be needing 3 main component here. So I'll be needing the bridge. The bridge will be the one responsible in bridging our devices and AWS Cloud. We also have auth, so basically for authentication, for us to be able to set policies and verify the devices that we have created and ensure that the devices are trusted. So the next thing here is, I'm not sure how this is pronounced. I'm not sure if it is Moke or Moket, but basically this is a solution for MQTT broker. So it will be the one responsible in, it would act as your gateway for your topics that has been published and for those topics that needs to be subscribed for. So I'll just enable this and then click next. So as you can see, aside from AWS CLI, we added 3 more components. So as long as it is available in the cloud, you can pretty much use it as is. And we could also do some sort of configuration as well, right? So let's do a configuration change with the auth ones. If we click this one and configure component, we should be able to see some sort of like this. But the thing here is that we just need to modify a configuration here. And since this is for authentication, I need to define policies. Okay, so I need to define policies. Later on, we will create this device, but for now, we will name it as my device, my client device, and then another one is my other client device. Okay, so meaning all of the devices that has this name will get to have this policy. This policy is actually those devices can connect to MQTT, can publish a topic or message to a topic in MQTT, and they could also subscribe to those topics. That's pretty much it. We'll leave all other field here as is because basically ito rin naman yung user that was actually created when we install the Greengrass runtime. So let's confirm that one. And then one more thing, I need to update the bridge. The bridge will be the ones responsible again in terms of connecting your devices specifically for the topic, right? So I'll just need to define a topic in here. So for now, we'll be using clients plus hello world. So as you can see, yung format ng topic natin is parang directory. Meron siyang slash. So that's how MQTT works. No? So I'll leave other fields as is or the default, and then that's pretty much it. I've added 3 available components. I configure 2 of those, the auth and bridge, and then I'll just click next. I'll just click next and then do a sort of deployment. So when I do the deployment, this component, the expectation would be this additional component should also be available or should reflect in our devices, which is running on locally on my machine. So it might take quite some time, but let's see. Let's have a quick check at it if it is now visible. Okay, I think it's still not. It's still deploying as of the moment. But again, as I mentioned, the expectation is you could manage your components, your piece of code, modularized code for a specific use case, and then deploy it using deployment, Greengrass deployment. And pretty much it, as long as you have registered core device and then you point it to that core device, it will then be deployed in there or it will be synced in there. Let's have another try. Okay, here you go. So it's now reflecting. We have now the bridge. We now have this MQTT broker. And then we also have the auth client in here. Now, the next thing we need to do is to check on if we can really publish message to the topic and if our devices can actually subscribe to those messages. But of course, we need to create 2 devices first, one publisher and then one subscriber. So as of the moment, I'll be creating it on the same device or the same machine just to save resources on my machine. No? I don't want to overload it because it might affect um, the demo given that we are also using Zoom, which consumes more resources. So I'll be deploying the publisher and then the subscriber within the same device. So for now, I'll be creating like, let me just check here. We create a new directory, greengrass, say component, not component device. CD greengrass device. And then C, let's create another folder here, device, ls. Okay, perfect. So now we'll be running a command here. I'll be just copying it. So I'll be creating one IoT thing, which will be like our publisher. So that's one here. As you can see, it is named my client device one. And it is actually connected to the policy I have pasted a while ago for the bridge, for the auth rather. So anything that has name with my client device, so it would then be registered. And then of course, I still need to create one more device that would act as the subscriber. If there is a publisher, there should be a subscriber, of course. So let's name it as my other device. And then do the same command above. Perfect. So let me just clear my screen. So basically, we just created 2 devices. My client device one would be that would act as publisher, then the other one would act as your subscriber. Let me clear this thing. Okay, as of the moment, we have these certificates available, certificate and keys. This would act as your authentication and for AWS to validate that you are really a verified device or registered device in AWS. So we also have let me just remove this thing. Okay, so here are the certificates, right? Now I still need to install a client which will be running on my machine. So let me just quickly install this. It would take quite some time, but hold on for a sec. By the way, while we're doing the demo and waiting for it to be finished, if you have questions, you can actually fire it, and then later on we will accommodate those questions. So now we have installed our client that will actually connect to the broker that we have, the component broker that we have installed using Greengrass, right? Greengrass deployment. Now, what I need to do next hmm, is to copy the certificate here. So what it does is it will copy the certificate of AWS Greengrass, the CA certificate or the certificate authority that would actually validate these certificates that is created per devices. So it's a sort of it's a way of validating things and ensuring that, okay, this is a registered one, this is connected to this CA, or this is actually signed by this certificate authority, a way of verification. So now for what we're going to do is to actually create or spin up our subscriber instance or device using this command. So the subscriber would be my other device one. So let me just clear this thing. As you can see, we have triggered mosquito sub. Would be our subscriber, and it will listen to this topic, meaning any messages pushed into this topic will get printed in here. That's the expectation. But now, as of the moment, it is not printed. The reason being is that we don't have a publisher yet. So I'll be moving on another tab in here. I'll just go to Greengrass device. Okay, perfect. And then here, we also be running our publisher. So as soon as I paste this and enter, what we will be getting is a message in JSON format, this one, together with the date, right? If I click this, oops, perfect. And if we go back here in the subscriber module, we should be able to see the message here, right? So that's how it works. So just think of this subscriber and publisher as different device or different or installed on a different device. It just happened that I'm just using one instance and then they are installed on the same device. But as long as they have connectivity to the edge runtime, which is the one we have installed a while ago, they could actually communicate to one another. So we could actually we could trigger multiple of this published message and we should be able to see this as well. Okay, so that's how it really works, no? On how we could communicate to devices, and then in the middle of it, acting as a gateway would be our Greengrass edge runtime, wherein that edge runtime is handling those components specifically for MQTT broker. Okay, so one quick thing as well, since it's already 2:49 p.m. Just a quick run through with additional use case. So this one is for AI ML naman, no? We will be moving to Cloud9 for now para mas mabilis since it is already created in there. So I just have to open this. By the way, Cloud9 is actually an IDE, almost same with VS Code. So if you're developing, you might be familiar with the UI. It also provides you a terminal where you could run codes. And it is actually backed by Amazon EC2. So it's still connecting. So while it's still connecting, if you have any questions, clarifications, violent reactions, you may fire it now. Let me just check the chat box if there are any questions. None yet. Okay, perfect. So in here, actually, this is part of a workshop. No? So what I'm going to do is actually, let me see if there are still, yeah, let's open this. This is the green grass logs. And then let me open another one. And this would be for the image classification. So think of this as the AI/ML inference happens not in the cloud, but on the device where you install the Greengrass Edge runtime. So it is actually now up and running. I think I do have problem here. Anyways, let us just check later on. So as of the moment, what I'll be doing is to open this image. Let me try this. This is actually an image of a chihuahua. And what we're trying to do is to let that AI/ML model determine that this is a chihuahua. And we could actually do that inference on Edge, right? And that's what we're trying to do now. So what I'm going to do first is to download that file, save it into a directory, and then, oops, I think I have deleted the directory, temp, image, or let us just create one, make dir, and then let us just rerun that thing. Okay, it was now downloaded. Apologies, it was quite small. Yan. So it's now downloaded and it should be available in slash image. Oops. Temp image. So there's an image in here, and that's actually the Chihuahua image. And then we will be like letting the component know that it is actually part of this directory. So let's have a quick view of how it would look like in AWS. So in here, I'll be just using this one as part of the demo. And in here, I have the DLR image classification. This one. So configuration is in here, as you can see. This is the, what do you call this one? The topic where those messages will be published. Basically, this is where we will be seeing the inference or the classification. And then, yeah, these are just the default ones. Pretty much straightforward. But for now, let us go back to Greengrass and check on if we could see some sort of a result. So as you can see in here in the logs, a while ago, right, I have enabled the logging. So as you can see in here, the inference result is actually Chihuahua, and then the score is 7.92. So most likely, it's a Chihuahua as compared to a Pomeranian. But, it's just point difference. Now, the good thing in here is that you could also see this result getting published in AWS. How can we do that? Let's go to AWS Greengrass, go to MQTT test client here. We could actually create a subscription of this topic, and then let me just retrigger it, right? I'll be just going back here, then I'll just retriggering it. Okay, so here you go. So you should be able to see something like this. The one that we have seen on the logs, which is directly running on the instance where your Greengrass Edge runtime is installed. And then this one naman is actually the ones being forwarded to AWS Cloud. So meaning we could have it processed on that device, on the edge device, and then just simply forward the result to the cloud if needed. if in need, right? So as you can see, this is the result of the inference. What if we try another example? So let's try another example just to ensure that the model is actually pretty good. Let me find the another image here. Here, I'll be pasting this one. So I'll be downloading this and overwriting the existing image, that JPEG. If I open this, where was it? If I open that file, it should be something like this. It's actually a dog, right? And then let's also prepare the other one. Wait, is it really? No, sorry, it's not the dog. It's one here. So it's this one. It's the parrot. So what breed of parrot is this? So let's try to do a restart of it just for us to be able to retrigger it manually. Because for you to be able to trigger it, there should be an action, right? And as of the moment, we don't have any action other than doing a force restart so that it would read and reprocess that file. Since it is just saved into this directory, sort of like that. So now I have triggered a restart. We will just wait for quite some time. A while ago, we see the image classification for Chihuahua, and it's pretty straightforward, right? As of the moment, yeah, we see a new result. Um, it's the result is actually a Macau. Just to be sure, what is a Macau? Let us search it. So actually, yes, it's actually a Macau with 9.59%. Not percent. This is actually not a percentage, I believe. Because I believe the highest here is 10. So 9.5 score. And then basically this model gives you the first five um, result. And basically the higher ones would be most probable the correct read of it. But basically that's more of AI ML stuff. But what I'm just trying to say here is that we could do AI ML inference at the edge and then forward the response to any other components, be it on the cloud, be it on the devices running locally within your organization. So that's pretty much it. I'll be now opening the floor for any questions, clarifications that you would like to ask. Let me just also remove my mouse so I can open my camera back again. Apologies for that, because I do have limited slots for USB ports. Hello, guys. Still there?
Yes, sir.
Cool beans. Let me just reopen my camera for a while. Were you able to
Open.
see me?
Yes, sir.
Well, I'm not seeing myself. So yeah, as I've mentioned, we are now open for any questions, clarifications.
Yes. Everyone may now send their questions into our chat box for later.
Here you go. I see my face back again. Anyone interested in IoT? Meron na bang mga graduating here? Like nagti-thesis na, since most of you are computer engineering, right? Most likely you will be dealing with devices, Raspberry Pi, Arduino. Have you think of like playing around with those, connecting it to any sort of cloud provider, right? For you to be able to leverage those wide breadth of services.
We have out of it yet, sir. Pero may yung batch po namin as of this moment.
Aha, nice. By the way, nagpuputol-putol ba ako? Hindi naman.
Hindi naman po, sir.
Okay. Perfect.
Sir, ask ko na rin po pala.
Go ahead.
Nakita niyo po bang CloudFront kanina and the like?
Mhm.
Free po ba yun magamit for for students like?
Actually, you could register for a free tier. And with free tier, you can play around with services, not only CloudFront. No? You could also play around with serverless. You could also play around with IoT and other services for 12 months. So, ayan, you would register. I suggest you register to AWS. Let me just look for the that thing.
Thank you. Sir, another from the chat box. What are the prior skills or tech needed to learn first starting in edge computing?
Prior skills and tech. Basically, um, depende sa gagamitin mong tools. Depende sa gagamitin mong devices. If you are into Raspberry Pi, I suggest mag-Python ka for developing your um, components, for developing your logic. And most likely, in the industry, no, for automation, most likely they're using Python already. But for some other instances, just for instance, kay AWS Greengrass, yung core component niya kasi is written in Java. So I guess you could have as well a bit of a knowledge or at least high-level understanding on how Java works kasi hindi ka naman talaga magmo-modify ng Java. You still have the power to use any programming language, be it Python, even JavaScript or TypeScript if you are using Node.js runtime, you could play around with that as well. You could also use Go. Because basically nowadays, no, in the advent of application modernization, you could actually package your component into containers. So you could actually select Python if you prefer Python. You can select JavaScript and then have it packaged and then deploy it easily. So there's no really a specific language, pero you have to have at least one core language. Even though software development, dapat merong one core language ka talagang alam. Na you feel like confident enough na whenever you ask to do this thing, alam mo i-implement. Ayun yung first thing. No? And then the second thing here is the concept in terms of the services that you will be using. Because most likely, multiple cloud providers has their own offerings. As I have mentioned a while ago, kay AWS pa nga lang ang dami na yun. So, may mga different use cases kasi na pinagagamitan yun. So, you just have to check on what services fits in with your requirements. And so, it is actually, so if it requires, no, within your organization, ayun yung gamitin mong service or ayun yung pag-aralan mo for you to be able to leverage its capability and benefits. So by the way, for the link, oops, it gets lost again. Oh, I see. I guess I need to open Cognito because I already have logged in with AWS. AWS free tier. Or you can simply search AWS free tier. You get to have like 12 months free services.
Thank you, sir. Any other questions?
Here you go.
Anyone? Oh, thank you, sir.
Of course, not only AWS, GCP also provides you free tiers. I believe meron silang $300 or $400 credits if you open an account. Pero that would be good only for 3, I guess, 3 or 6 months or so. Pero at least if you're playing around with cloud or if you're exploring with cloud, that would be a great help na rin. It's a sort of a trial rin, trial period ng mga cloud provider. Even other cloud provider meron silang paid model. Alibaba, Oracle, Azure, meron yun. But as of the moment, maybe you would explore AWS because AWS is one of the leading cloud providers as of the moment, followed by Azure, GCP.
Right? It seems like there are no more questions, sir.
Okay, great. Let me
This
just
juncture, I am now calling Mr. Jacob Santos in the attention of our tech team to proceed with the awarding of certificate and the evaluation link for this webinar in our Zoom chat box. Proceed with the photo opportunity with our speaker.
Okay, thank you. To express our gratitude toward our speaker. Uh, okay, we express this certificate of recognition to Sir Romar Cablao for imparting his knowledge and valuable insights as webinar master for the webinar Edge IOT Meets the Cloud during the Virtual Software Engineering Day 2022 organized by PUP Computer Engineering students. We thank you for your support and active involvement in this event. Given this 11th of June 2022 at the Polytechnic University of the Philippines, College of Engineering and Architecture Building, Anonas Corner, Poresa Street, Santa Mesa, Manila. Signed by our head webinar organizer, Jason Matthew Season, our course advisor, Dr. Arvin de la Cruz, PCPE, and our chairperson of CPE Department, Engineer Julius S. Cancino, PCPE, and the Dean of College of Engineering, Dr. Remedios G. Ado, PCPE. Okay, thank you, sir. So this is the certificate of recognition.
by the
And
way, yeah. By the way, thank you as well, no, especially to Jason and the whole team for putting this up together and also for inviting me and trusting me as a resource speaker for this event. Thank you, guys.
Thank you din, sir. Sir, may naglakin. I have a quick question daw from Miss Jennifer Kahulugan.
Wala na po, close na po, sarado na. Just
Oh,
kidding. Go ahead. Go ahead.
ayan. Sorry. For help or questions, should we need to implement edge computing?
Sorry, it's a bit choppy, but let me reread it now. Can we contact you for help or questions? Should we need to? Yeah, of course. Yeah, you can actually contact me. Maybe I could flash another screen as well. Or yeah, maybe Sir Jason or the team could also share my email address or my LinkedIn account to you guys for you to be able to reach me. Yeah, I'm happy to help you guys.
Kunin ko lang po, sir. Wait, sorry. Mm.
By the way, let me also share with you some of the helpful links just in case since we haven't like run through all of the demos as in from the beginning, right? So maybe I can share you some links where those activities are actually available and could be done at your own pace. So you could just like sign up for free tier, and then when you sign up, you can follow along through these workshops or sessions here. So it's actually a guided lab, the same that I have presented to you a while ago, but the way I presented a while ago is not step by step, because we normally do a step by step walkthrough for 3 hours long, then specific lang talaga for specific service. But for this, since we're using CDN and then IOT Greengrass, we just have it like forwarded, or parang gist lang nung process or steps within that workshop. But yeah, you can play around with those. Actually, it's not only available for IoT Greengrass and for CDN. If you are interested working into containerization or into serverless, you could also search for those workshops, and this is available over the internet. Plug ko na lang rin, no? If you would like to explore more of on AWS, you could attend our sessions. Sometimes we do sessions, no, together with AWS. I am actually from at Point Technologies, and we do talks. And I also suggest yung mga sessions ni Siklab Pilipinas, AWS Siklab Pilipinas, though I'm not a part of it, and Education PH. They are really creating events just to how do you call this one? Just for them to be able to like explain AWS services to not only to students but also to those in the industry who would like to shift into cloud engineering. So yeah, that's it. I think I'm
Say a few words. Mr. Santos would like to say a few words for closing.
Okay. Thank you so much, Jason. So again, good afternoon, everyone. This marks the end of our webinar entitled Edge IoT Meets the Cloud. I would like to thank each and every one of you for attending and actively participating on our webinar for today. I hope that all of you learned a lot about the topic that will be useful in your future endeavors. Also would like to thank Mr. Romar Cablao, our guest speaker for today, for sharing with us his expertise and knowledge and giving us a very insightful webinar. And to Dr. Arvin de la Cruz, thank you for giving us his continuous support as well. And to the organizers, thank you for organizing this event. I would also like to remind everyone to answer the evaluations forms for you to receive your certificate of participation for this webinar. You can find the link on the chat box. It was sent by our organizers. And again, there will also be a closing ceremony back in the main room and the announcement of raffle winners and the prizes. And you may now leave the breakout room by clicking the leave room icon and select leave breakout room. Once again, thank you everyone.
Good job mga pre.